Hello, Algebra 2A. Welcome back to another episode of our video notes. On behalf of Miss Garrett, Mr. Hanson, Mr. Rengel, welcome. We will be looking at lesson 28, Simplify Rational Expressions. And in this lesson, a big skill we're going to use is factoring. So we're going to start out looking at the warm-up here and doing a little practice with factoring. The two types of factoring that we'll use today are factoring a GCF, which we'll see in number 3, and then factoring a difference of squares. We'll also be factoring trinomials. If you're looking to get more help with factoring, we did this in lesson 23, and your lesson 23 Delta Math assignment will still be on, so you can always go back to review that and get more practice with factoring. In problem 3, we are going to factor using a GCF. So GCF stands for greatest common factor. So we are going to look at all of our terms. We're going to look at a number that both numbers can be divided by. Then we're also going to look for any variables that they have in common because we're looking for the greatest common factor. So looking at negative 12 and 15, I can see 12 and 15 are both divisible by 3. So that means they have a factor of 3. Now, one little hint is we always want to make our term with the highest degree, we want to make that positive. So I'm going to divide by a negative 3 or factor out a negative 3 out of both of these terms to make that leading term positive. It's just going to make it easier for us with our factoring later on if we make that first term positive. Next, I look at the variables. I have an x to the 6th and an x to the 5th. So the greatest number of x's that they have in common is 5, x to the 5th. So I'm going to factor out an x to the 5th. Now looking at the y, there's only a y in the second term, so they do not have a greatest common factor together with y's, so I can only take out the GCF of negative 3x to the 5th. Now to rewrite this in factor form, I'm going to put my GCF out in front and start to set up what looks like a distributive property problem. Very similar to what this is up here. So I'll take negative 12 divided by negative 3 gives me a positive 4. X to the 6th divided by x to the 5th, I'm just going to subtract 6 minus 5, leaves me with x to the 1st. 15 divided by negative 3 is negative 5. X to the 5th divided by x to the 5th, those will cancel, and then I'm left with a y. So there would be my factored form of number 3. In problem 2, we're going to be looking at difference of squares. So a difference of squares is where we have a situation in the form a squared minus b squared, where both a squared and b squared are perfect squares. Now, a perfect square for numbers are numbers like 4, 9, 16, so on and so forth. For variables, we're looking for any variable that is raised to an even power. If it's raised to an even power, we can square root that. So this difference of squares is always going to factor into a plus b, a minus b. So I look at my problems. I got a 16x squared. 16 is a perfect square. X squared is an even power, so that I can square root. I can also square root y squared, but I have this plus sign here, so that is not a difference of squares. 8 is not a perfect square. Can't use that one. 9 minus 50y to the 6th, 50 is not a perfect square, so that leaves me with D. Now, since I can square root x to the 10th and I can square root 100, I can factor that. So let's look at that factored form. So I square root x to the 10th. So square root of x to the 10th would be x to the 5th, because x to the 5th times x to the 5th would be x to the 5 plus 5, which is 10. Square root of 100 is 10. So I'm going to have now x to the 5th plus 10 times x to the 5th minus 10. There would be my factored form. So there would be my difference of squares. So we're going to see a difference of squares a lot in this section, and then also in section 31, where we continue to look at rational expressions. So that is going to be a big skill that we'll practice in these next few lessons. Our new concepts that we'll talk about in lesson 28. So we're going to look at simplifying rational expressions. So what is a rational expression? Rational expression is a quotient of two polynomials, or in other words, it is a fraction whose numerator and denominator are both polynomials. Excluded values. Excluded values are a value for x or any variable that the rational expression uses that makes the denominator 0. And simplified is when there are no common factors in the numerator and denominator. In example 1, we are going to find any excluded values, and then we will simplify the expression. So on the left side of my blank space here, I'm going to use EV to represent excluded value. So excluded value means you take whatever's in the denominator. So here I have 8y squared, and I'm going to set that equal to 0 to find out what number could I put in for y that would make it equal to 0. Well, I could do a little algebra, but if I have 8 times y times another y is y squared, well, whatever, I'm going to have y equal to 0. So my excluded value is going to be y equal to 0. So there is my excluded value. Next, we'll look at simplifying. So we'll start by taking the excluded value, z to the fifth, setting it equal to 0. So z to the fifth is just z times z times z times z, which is going to be 0. And then I'm going to start to simplify my rational expression. I've got a z to the first up in the numerator. If I look, I've got 5 z's down in my numerator. This z in the numerator will cancel out 1 z down in my denominator, which leaves me with 4 down in my denominator. So z divided by z in my numerator is 1. So here I do have to put the 1 to represent that. And then z to the fourth would be in my denominator. So I'm left with 1 over z to the fourth. Heading down to example 2, we again will find our excluded values and then simplify our expression. So let's start with the excluded values. So remember, excluded values are any value for your variable that makes the denominator 0. So what you do is you just simply take your denominator and set it equal to 0. And here we do a little algebra. We can subtract 2 on both sides. We'll get x is equal to negative 2. So if you put a negative 2 into that x down there, negative 2 plus 2 is going to be 0, which makes my rational expression undefined. So there's my excluded value. Next, we're going to look for any common factors. Now, since this is a binomial or a two-term polynomial, I need to factor this first to see what its factors are. So I've got my 2 parentheses x squared minus 4. Now, thinking back to that number 4 in our warm-up, we're going to see if this difference of squares applies here. So x squared is an even power, so I can square root that. And then 4 is also a perfect square, and it's a subtraction. So I can square root both of these, which is going to give me x and 2. So that means I'm going to have factors of x plus 2, x minus 2. So all these difference of squares will factor the exact same, x plus, x minus, all over x plus 2. Next, I look at, I've got an x plus 2 and an x plus 2. So since those are the exact same factors, I can divide a factor of x plus 2 out, and then I'm left with 2 times x minus 2. And that would be my simplified form, and then that's what I would put in my answer for Delta Math. So that concludes our notes for the day 1 of lesson 28. If you stick around, I will show you how to complete one of these problems on Delta Math. So in our first section, it will be called dividing powers. So here's where we're going to look for common factors in our numerator denominator. So I have an 8 and a 4. Well, 8 can be divided by 4 to become 2, and then 4 can be divided by 4 to make 1. X to the 5th over x to the 7th. Now I have 5 x's up here, 7 down here. So all 5 will cancel out. 7 x's, if you cancel out 5, you're going to have 2 left. So that's an x squared down your denominator. And then here we have a y to the 6 over y squared. So if 2 y's are in the denominator, it'll cancel out 2 up in the numerator. You still have 4 left up there. So you're going to have 4 y's, or y to the 4th. Now here's how you would enter it in. You'll hit 2y and then shift 6 and then hit to the 4th power. Then you can hit out to get out of your exponent, hit the fraction button, which is right next to shift, the backslash. And then you can hit either 1x squared or simply just 1 squared. So shift 6 and then put a 2 up there. So that should be our result. And then we'll walk through the process. It'll show you how to complete it. Our second group of problems is called simplifying rationals. So here we have a polynomial in our numerator, a polynomial in our denominator. Now we don't have to find excluded values, but we do have to factor both of these polynomials to find what factors they have in common. Up in my numerator, I have a trinomial. So all trinomials that we are going to deal with are going to factor into two binomials. Since my a term is 1, I'm looking for two numbers that multiply to 5 and then add to 6. So that's going to be x plus 1, x plus 5. Now I head to my denominator. Now if I look, I got x squared minus 1. X squared is an even power, so I can square root that. And then 1 is also a perfect square. Square root of 1 is just 1. So that's going to factor into x plus 1, x minus 1. Now from there, I look, are there any common factors? Yep, x plus 1, x plus 1. So there's going to be my simplified version, x plus 5 over x minus 1. And here's how you would type that in. So we'll start by hitting x plus 1. Then you can hit your fraction button, which I thought that might happen. So let's try this. Parentheses, x plus 1. Close off your parentheses. Now hit the fraction button. That'll leave your x plus 1 in the numerator, which it's not really an x plus 1, is it? It's an x plus 5. Whoops. Down your denominator, then we'll put parentheses x minus 1. Close them off. So we got our trinomial factored, we got our difference of squares factored, and then we just look. You'll always see a common factor that you can factor out. There we go. Now we hit submit. And then they'll walk through the process. Remember, right here, there are help videos. So I know that we just went through a couple, but you might be struggling on a current one. That's an easy way just to click on that, and you'll have a little video to kind of help you out. Well, again, thanks for joining. You are now ready to start Lesson 28, Day 1.